Good evening, folks. I'm Victor Lin of Chem 13 News with a breaking news story for today. A recent report found that extreme weather events like drought, hurricanes, and wildfires caused billions of dollars of damage in 2018. They have been linked to climate change caused by humans because of greenhouse gases, increasing the average temperature of the planet. These extreme weather events can all be explained by kinetic molecular theory. Regarding drought, as temperature increases, the average energy of liquid water molecules increases. Then the proportion of water molecules with enough energy to vaporize into gas increases, and bodies of water evaporate. Hurricanes, such as Hurricane Florence and Michael, become stronger when traveling over warm waters. Warm waters heat up the air above it, causing it to rise. Cooler air replaces the air that was warmed, and then is also warmed by the water. This circulation of air, combined with the rotation of the Earth, creates hurricanes. Warm air is less dense because as the average speed of the molecules increases, the molecules tend to take up more space. Global warming is increasing the temperature of the water, resulting in stronger hurricanes. Combustion reactions tend to be spontaneous because they are very exothermic. However, a reaction does not take place unless the colliding molecules have enough energy to surpass the activation energy. One of the reasons water helps to put out fires is because of its high specific heat and vaporization energy. In dry conditions, such as drought, there is less water present, so it is easier for the activation energy of combustion to be reached. In these conditions, a small spark or ember can provide the activation energy, starting a wildfire which is difficult to stop once it has started. And here's Clinton with a business story for today.
Thank you, Victor. On the 17th of October 2018, Canada became the first developed nation to legalize recreational cannabis indica, more commonly known as marijuana, to the general populace. Such news was met with massive numbers of Canadians waiting in line for government-run retail shops selling pot. One might question the purpose of recreational cannabis with respect to its scientific application. In essence, common marijuana is a psychoactive drug that contains a core organic molecule known as THC, which acts on the brain to alter neurotransmitter release. Generally, THC also refers to the various isomers of the molecule, which serve similar purposes. THC receptors are present in the majority of cells in the body, meaning that the effects of THC are wide-ranging. Primarily, and the reason that many people use it in the first place is that THC affects the brain's release of neurotransmitters responsible for the brain's reward system, making us feel good. However, extensive and excessive use of marijuana may lead to a decreased sensitivity in THC receptors, thus requiring larger and potentially dangerous doses of cannabis to achieve similar effects over time. With that in mind, the legalization of recreational marijuana is predicted to create an industry worth several billions. Concurrently, however, the market value of cannabis is also projected to plummet. Such legalization is recent, and it is also a concern that the legal market's competitor, the cannabis's black market, which harbors highly loyal customers, will stunt growth of the industry initially. For those who are interested in startup businesses regarding the sale of legal cannabis, much of the current industry is unexplored, undefined, and unknown. Thus, experimentation and experience in business will be the factors that decide which marijuana retailers are successful and which ones are not. That is your daily news for the dank weed.
So, Kerry, tell us about this new technology.
So scientists from the University of Washington have been able to construct human tissue from proteins under laboratory conditions. In the past, signal proteins are modified by attaching chemical groups to random locations. Sadly, this method causes a protein to lose 90% of its function. This new technology keeps the proteins intact and functional by only modifying them at a specific point.
Wow, does this mean I can have two stomachs?
Not yet. The technology has not yet advanced to a stage where the specific organ tissue can be constructed.
So, how does this all work?
Well, this approach uses an enzyme called sortase. It is able to add a short synthetic peptide to the C-terminus, a site that is present on every protein. This peptide will be able to tether together the signal proteins to specific locations within hydrogel, a fluid-filled biomaterial scaffold.
Sounds complex, Kerry. Well, looks like we're running out of time here. Is there anything else you would like to explain?
The tethers formed by the proteins can be cut with focused laser light, causing photorelease of the proteins. By selectively exposing only portions of the materials to the laser light, the team can control where the protein signals would stay tethered. The untethered proteins can be brought to the cell's interior where they can affect processes like gene expression.
Alright, that's it. Thanks for coming, Kerry.
I'm happy to be here.
Today's story is about a new wearable device that is capable of measuring the cortisol levels in an athlete or patient's sweat. Cortisol is known as the stress hormone and is often released during times of stress. It is also involved in many physiological processes, including metabolism and immune responses. Although we've had ways to measure cortisol before, the current methods usually take several days in a lab to produce results. By the time these results are on hand, cortisol levels are likely different from when the test was taken. A group led by material scientist Alberto Salio at Stanford University has created a patch that, when applied to the skin, can pick up sweat and assess how much cortisol a person is producing. Clinical tests of cortisol can gauge a person's emotional and physical stress. One of the biggest challenges in the creation of this device was a sensor that can actually detect cortisol. They achieved this by creating a cortisol-sensitive membrane, which only allows small, charged ions to pass through. The big cortisol molecules get stuck in the membrane and clog the passage. The sensor, which actually detects the presence of ions, can measure the decrease in ions and turn that into cortisol data. Although this design is relatively new, many tests have already determined that the device works as intended. The prototype seems to work multiple times as long as the patch is not saturated with sweat. The researchers' next step is to use their general design and apply it to other biomarkers. In the future, they want to create a device that can measure multiple biomarkers at once.
Scientists recently determined a way to store information within molecules. Here is Bell to discuss more about this method.
Thanks, Kerry. Well, to sum it up, all current methods of storing information can get destroyed. Books can get burned in a house fire, CDs and DVDs can get scratched, and computers can get hacked. Recently, scientists at Harvard have figured out ways to use simple molecules called oligopeptides to store information that cannot be destroyed through virtual or physical means.
So, how does this work?
Well, scientists use this relatively cheap molecules called oligopeptides. Each molecule consists of different masses in many different holes called a microwave. This allows reading and writing data quite simple. Using a mass spectrometer, it is able to separate the peptides by mass and allows you to read the data you encoded. With only one synthesis, one can produce many small oligopeptides and encode many different files using binary code.
Oh my god! How much storage can this method store?
A mixture of 8 oligopeptides is able to store 1 byte of information. Because of how small the molecules are, you'll be able to store thousands of documents and videos within one small box.
Is this method considered reliable?
It's pretty reliable, as currently, scientists at Harvard were able to read our encoded data with 99.9% accuracy, meaning there's little to none data loss. We can write it at about 1 byte per second and read data at the speed of 5 bytes per second.
That's like faster than me. Okay, thank you for your time, Bell.
It was a pleasure being here, Kerry.
Amen.
And that concludes our edition of Chem 13 News. Thanks for watching and see you tomorrow.